Hi everyone, I'm Melissa Illingworth. This is my video about calculating the pH of a salt solution. So here's a salt solution of sodium acetate, and we know it's 0.15 molar. The first thing I like to do is to find out how each of these ions are going to interact with water. So first, start with sodium plus water. When an ion interacts with water, it's going to either pick up a hydrogen or pick up a hydroxide. That's the way water splits up. Sodium is going to pick up hydroxide to become sodium hydroxide, and that leaves behind the hydrogen. But this reaction, well, it creates sodium hydroxide. That's a strong acid, or sorry, a strong base. And for that strong base, it's actually not going to stay there as Na and OH together. It's going to completely dissociate. So this reaction, instead of drawing like an equilibrium arrow, it's really only going to go in one direction, and that's the reverse direction. These products are not going to be created. So sodium is not going to affect the pH of the solution one way or the other. For acetate, though, it's a different story. When acetate reacts with water, it's going to gain a hydrogen, becoming acetic acid, and what's left over is hydroxide. So this reaction creates a weak acid, acetic acid, and so that is actually going to create some products here. So we're going to get some hydroxide ions made. So will this solution be acidic or basic? From the sodium, that doesn't affect the pH one way or the other. For the acetate, that's actually creating hydroxide ions. So the solution is going to be basic and have a pH somewhere above 7. Now we want to actually find that pH, and we're going to do that through creating a rice table. So that reaction that actually got to products is this one with the acetate ion. And in this rice table, I'm going to leave out water. It doesn't affect our equilibrium. So there's the reaction. And for our initial concentrations, we know this one is initially 0.15. These, oh, sorry. These are 0. And for the change, we are going to create our products, decrease the concentration of the reactant. They're all going to change by the same amount, whatever that is. Just put X to stand in for it. And at equilibrium, this reactant's going to decrease by X. These others will increase by that. So here's this reaction that we have above. And this we have CH3COOH, sorry, our reactant here, CH3COO. And here now, CH3COOH is our product. We have just gained a hydrogen in this reaction. This is a base reaction. So this equilibrium process that's happening is for a basic process. We don't need a Ka, which we would find in the table. We can find the Ka for this acid. We need the Kb because it's a base. We're gaining hydrogen. So the Kb is what we need for this reaction that we had in our rice table. Where here are our products, acetic acid and the hydroxide ion, and our reactant is the acetate ion. So we need the Kb. But when we look at the table, we can find the Ka of acetic acid. That's 1.5 times 10 to the negative, sorry, it's 1.8 times 10 to the negative fifth. There. So to find the Kb instead, we're going to take this constant and divide it by the Ka that we know. That gives us 5 repeating, and that is our Kb. And that number is what we're going to use now to then plug in with the information from our rice table. So here, now our two products, x squared. So there's everything from our rice table. I'm going to go ahead and simplify this and get it into the quadratic format. All right, so now we have our A, B, and C terms for the quadratic. And when you solve this, you'll get 2 options. And when I have numbers like the ones for our B and C terms that are 2 these really small exponents, I do use a computer program or website to solve the quadratic for me. It's just quite a pain to do it by hand with those small numbers. So for here, we have 2 values. We have a negative value. Well, one, that answer we won't ever use for our concentrations. So this 9.13 times 10 to the negative 6 is our value for X. And that from our rice table is also our hydroxide ion concentration. So now we know our hydroxide ion concentration. We can find the POH, negative log of that answer. So our POH is 5.04. And then 14 minus that value gives us the pH, which is 8.96. All right, so there's the pH of our salt solution. We knew it would be basic, and here it is at an almost 9 pH. So that's the video solving for the pH of these salt solutions. Thanks for watching.